Okay, in this video, we're just going to briefly look at one or two problems from your book on harmonic motion. And essentially, as far as it goes, what we had said before is harmonic motion equations are of the form y equals a cosine omega t or y equals a sine omega t. And while we're calling these harmonic motion equations, ultimately, they're just trig functions. This a right here, we've done it before, the leading coefficient, that's the amplitude of your problem. In this case, it'll be the amplitude of your spring, how far it moves. This omega right here, that just dictates my period. And we know the trick, whatever that coefficient is, whatever that omega is, to find the period, you do 2 pi divided by omega. And that equals your period. And then if you're looking for the frequency, you just take whatever you get for the period and take the reciprocal of it. So, the frequency is equal to omega over 2 pi. And again, much like with the rectangular and polar coordinates we just did, this is no different than stuff we've done before. We're calling it something different because it's an application, but it's a trig function. It's a trig graph. There's my amplitude. There's my omega that changes my period. Okay, good. So the problem in your book, and I'm not going to write the whole problem on the board. It's in your book. It's problem number 28 on page 674. You guys can turn there, pause the video, turn there if you want. It's from your homework. But let's see. You are told you have a water wheel that is 30 feet in diameter. It makes 2 revolutions per minute, counterclockwise. And if you graph it, and we'll just graph it to make it as easy as possible, assume that the bottom of the water wheel is at the surface of the water, and it starts right at the point 0, 0. So you have a nice little origin set up. And at time 0, you start right at the bottom right there. Then it says, write a function, the problem you have to solve for homework, write a function that determines the x position, which is the horizontal position, and the y position, the vertical position. Well, if you think about it, here's where you have to be able to visualize these things and see what's going on. Essentially, I have a water wheel. I'm not good at drawing circles, but we'll try. Say it looks like that. If this is the center, we don't really need to find this point, but if that's the center, this distance is 15 because the diameter is 30, which makes this 15, and then logically this is 15, and that's 15. You don't need to label all those out, but if it helps visually, you can do that. So let's see. I want to find a function that dictates what x is at any given time. X is my horizontal position. Well, if you think about it, I'm going to go counterclockwise, which, let's see, clocks go this way, so counterclockwise is this way. When I start, I'm right here. X is at 0. So maybe if I graph it over here, when I start at time 0, x is 0, right here, right at the origin. As time starts moving forward, my x value, my distance from the center, gets bigger and bigger and bigger. So it goes up. The furthest I'm going to get from 0 is right here at the edge. Horizontally. Again, we're not concerned with the vertical here, just the horizontal. Horizontally, this is the farthest I can get from there. And it's a distance of 15. Then, once I reach that point, what happens? The wheel keeps turning, which means my horizontal distance starts getting smaller. It goes back to here, which is the same horizontal distance at the origin, 0. Which means my horizontal distance gets smaller until it goes back to the origin right here. But then the wheel keeps turning and I start going this way, horizontally. And in terms of the graph, that means the x's get negative. So the x's start getting negative. They'll keep on getting negative until right over here, the furthest point I can go horizontally on this side, it's negative 15. Then they start getting smaller again. Smaller as in amplitude back towards 0, which means I start going back to 0. And I get that graph right there. Well, that's just a sine graph. So that tells me I just have a sine graph right here. So, write it out. X equals A sine omega t. Now, just like when we graphed these before, I just need to find A and omega. A is my amplitude, but clearly I go up to 15 and down to 15. Amplitude is 15. To find omega, we said 2 pi over omega is the period. We're told I make 2 revolutions per minute. So then let's see, what is my period? If I do 2 revolutions per minute, then I do 1 revolution in half a minute, which means my period is 1/2, half of a minute. So then I can just say 2 pi over omega is equal to 1/2. Now just solve for omega. If you cross multiply, omega times 1 is omega, 2 pi times 2 is 4 pi. There's my omega. So my equation becomes 15 sine 4 pi t. And there we go. One way to test this, pick different times, plug them in here, and see if you get the horizontal distance you should. I'm going to leave that to you guys, so I don't have to spend a lot of this video just plugging in points. But pick different times. This is time 0. At what time should you be out here? Do the math and figure it out. You know how fast you're going. Plug that time in, and make sure you get the value you should. Figure out when you should be up here, or in this case, horizontally, when you should be back at 0. Plug that time in, and make sure this equation gives it. It will, so test that and see. But now, do the same thing for y. So, let's see. For y, what happens? Well, maybe this time we'll throw the graph over here for y. And we'll just move our equation to this side. Let's see, for y is the vertical distance. When I start, I'm at the bottom. So I guess my height is 0 right here. And then as I start turning, I go up. I go here, all the way up, in this case, to the top, which is 30. So I guess I'll just go up to 30. Once the wheel reaches this point and it's at its maximum height, it starts coming down. So my height decreases. It goes all the way down to 0. What graph is that? This is clearly, if you can't see it, going to keep on going back up and down and up and down. So it's definitely a trig function. And in this case, we're not starting at equilibrium. We're starting at the max or min, which means it's a cosine wave. So we need y equals a cosine omega t. Let's see, A is my amplitude. Clearly, the total distance I travel is 30, from 0 to 30. My amplitude is half of that, so it's 15, just like the one before. So, y equals 15 cosine omega t. What's my omega? Well, it's moving at the exact same speed, so I could do the math again. The math will be the same as here. And I'll go get omega is 4 pi. So I can replace this, 15 cosine 4 pi t. But here's where you have to remember the things we did when we did graphs of trig functions before. How is this different than a regular cosine graph? A normal cosine graph starts at maximum and goes down and then up. This one starts at minimum and goes up, which means it's not a cosine graph, a regular cosine graph. It's flipped, which means I actually need a negative sign right out here. So y equals negative 15 cosine 4 pi t. But then again, if this orange is my regular cosine graph, it goes positive to negative. Or if you flip it, negative to positive. This graph is always positive. So it's not really a regular cosine graph. The regular flipped cosine would start down at its equilibrium, go up to maximum, and then go back down. This one starts above it. So how do I account for that? Well, essentially all I do is move the whole thing up. How far do I have to move it? Well, the amplitude is 15, which means I'm getting negative 15 at 0. I want it to be 0 at 0, so I just have to shift the whole graph up 15. So I go a plus 15 on the end, or you can put it at the beginning, it doesn't matter. And now that's my equation. And I will grant this can be a little bit tricky, that's why I had you do it for homework to ponder it. Ultimately, do exactly what I said right here. Plug in points. If you can get to just this part right here, which is all straightforward, cosine graph, we know the amplitude, we know the period, oh, but it's flipped, so we make the negative. If you can get all that far, that's good, but then plug in points. If you plug in 0, cosine of 0 is 1 times negative 15, you get negative 15. At time 0, is the wheel at height negative 15? No, because height negative 15 is down below the water. You have to shift the whole thing up. So always just plug in points when you're done to check to see if your graph is correct, to see if your function is correct. Because if it doesn't work, then your function can't be correct. But once you check it, you can say, oh, I got negative 15, I should get 0, I have to add 15 to it. Now plug in a few other points. Again, I'm not going to save time. But plug in a few other times, see what height you get, and see if it makes sense. For the purposes of this one, I need the plus 15 because my height can never be negative. My water wheel would be underwater then, and that's not really what I'm going for here. Okay, like I said, I need to make one more video covering bearing problems, and this thing won't have enough time left on it, so I'm going to do a separate video for that.